A new family of ultrasound probes based on MEMS transducers is currently emerging. CMUT components are constructed on silicon and have a significant potential in terms of wideband operation, good thermal efficiency and low fabrication cost. This video describes a robust and repeatable experimental protocol for assessing the capabilities of CMUT ultrasound probes in application to brain imaging during the early prototyping stages of design and development. Capacitive micromachined ultrasound transducers, or CMUT for short, are microfabricated arrays of tiny electrostatic actuators, each acting as a two-way ultrasound transducer. More in detail, in each CMUT cell, an electrical excitation produces a dynamic force that induces mechanical vibration of the moving plate. The acoustic waves thus generated propagate into the medium. The effect is reversed during reception. Acoustic waves generated by tissue scattering cause vibrations of the moving plate that change the capacitance of the CMUT cell. This produces an electrical signal which is further amplified and transmitted to the ultrasound system. This is the linear CMUT probe used for the experiments shown in